Question number 9. Given g of x equals x squared minus 2, evaluate g of negative 3. G of x is negative 3. That means in the x spot, we're going to plug a negative 3. So if you choose to do this by hand, that means in this x spot right here, we're going to plug in a negative 3. So we're going to say negative 3 squared minus 2. And I'm going to write this one out so that you don't make one of the common mistakes with the negatives. Negative 3 squared looks like this. We're going to write negative 3 twice in the parentheses, and then we're going to do minus 2. We're going to do our order of operations. There's nothing inside the parentheses that we can work. We did exponents right here, and I wrote those out. And now we're ready to multiply or divide whatever comes first from left to right. And I see multiply, so we're going to multiply negative 3 times negative 3. 3 times 3 is 9, and a negative times a negative is a positive. Positive 9 minus 2 is going to be 7. So if you choose to do that by hand, that's how you do it. If you want to use the technology, the Desmos, you are going to type in the equation that you see exactly like you see it, and in class, to practice this, we put the box. And then there's a couple other ways that you can do this. You can also type in this next part in a box. And we can type in g of negative 3. And then right here it tells you your answer. Oh, you can't see that on the screen. There you go. Your answer is going to be 7. So that's another way to get the same answer of 7. Another way that we did this was with the table. If you type in that first box, you can change it to a table, and a lot of students like this way. And in the x column, we want a negative 3. So in the x column, I can type in a negative 3. And again, I can see my result is a 7. So you have several different ways that you can do that question. And you'll do the same thing for question number 10. Given h of x equals 3x minus 4, evaluate, oh, that should be an h of 12. So we're going to put h of x, so the x is going to be 12, and we have 3 times 12 minus 4. 3 times 12 is going to be 36. Minus 4, and we're doing this because multiply comes before subtract. It doesn't matter that it comes first in the line, and then we get our 32. We can also type this one in our Desmos. We can type in, oh, you didn't see any of what I just did. There it is. So you can type it into Desmos. You can type in h of x equals 3x minus 4. And you can type in, I just did this. You can also type in this one, and remember this was supposed to be h of 12. So we could type in h of 12. And our answer is right here, 32. You can also change it to a table, and we want that 12 in the x column. So I'm going to go back up here and change it with our gear to a table. And I'm going to go type in 12. And you can see the answer is a 32. So again, 3 different ways to get the answer of 32. Question number 11. Domain and range word problems. Determine which of the statements describes the domain and which describes the range of the problem situation. So remember, domain is going to be talking about your x, and x is going to be going sideways, left and right, like the x-axis. So we're going to be looking left to right. What's the farthest to the left that our graph goes? We're only allowed to look at these numbers for the x on the x-axis. It goes over here to 0. And then what's the farthest to the right it goes? Well, the arrow goes over here by this 5, but it's an arrow. So the arrow means that it's going to keep on going. Our line is going to keep extending. So where is it going to stop? It's going to stop over at infinity, which means it never stops. So we need the answer that includes a 0, and that's it. All the numbers are bigger than 0 because it can keep going this way. And instead of saying bigger, we would say greater. So that's not a 0, that's not a 0. There's a 0. All real numbers, so that includes all the decimals, all real numbers greater than or equal to 0. That's going to be it right there, but let's double check our other choices. All real numbers less than would be going lower, and that's not what we want. And here it's between, and here it's between. We don't stop at that 5. We have the arrow. The arrow means it keeps going, so this is our domain. For range, the range of the problem, range is talking about our y values. The y-axis goes up and down, and when we look for the range, we're looking low to high. How low does it go to how high does it go? So let's look for those numbers on the y-axis. So on our y-axis, how low does it go? Well, the graph is going to keep going because of that arrow again. So the lowest it's going to go doesn't stop. So we put negative infinity. What's the highest it goes? It goes up to 5. So it's 5 and everything lower, everything less, everything that goes down. And so we're going to use that vocabulary word less than. So we're focusing on that 5. All real numbers greater than. Greater than when we're talking about y would be going up, and we're not going up, so this is not going to work for us. All real numbers less than or equal to 5, that's going to be going down. That's going to be what we want. Let's double check the rest of our answers just to make sure. All real numbers less than or equal to 0. We don't have that 0 on here. We're focusing from that 5. Here's a 5 and here's a 5, so let's check those choices. All real numbers less than or equal to 5, but greater than 2. That would be between here. Less than 5 would be down here, and greater than 2 would be here. And again, that's not going to be accurate because that arrow keeps us going. This is just between. And then all real numbers greater than 0, so that would be up from 0, but less than 5 down. We keep going because of that arrow, so this won't work. Our range was up here. We only had the one boundary at the 5.